The warm-up, just adding and subtracting like terms, basically adding, subtracting polynomials. So we should get 8x to the 4th minus 8x squared plus x plus 2 for the first one. The second one is a minus, so I should get negative 7x to the 4th minus 2x plus 4. The third one, minus 4x cubed, minus a minus is plus 14x squared, minus a minus, plus 15x minus 1. And then the fourth one, let's see, 6b to the 4th minus 6b squared, that's 0, minus 6. I think that's right. So, any questions? Okay. So we're going to move on, and today we're talking about rational. We're moving on to a new unit, and it's rational functions. Rational, let me see if I can get it so everyone in here can see too. So rational expression is nothing more than a fraction in which the numerator and or the denominator are polynomials. So in order for it to be a rational expression, both the numerator and the denominator has to be a polynomial. So the first thing we're going to do is just circle those 6 expressions that would be a that would be a rational expression. So if you'll circle them if they're a rational expression. Thank you. I think there's 4 of them that are rational expressions. And who did I just sign in? Oh. And Melanie. Here, not here. Not here. Okay. So is the first one a rational expression? Yes or no? Sorry, I can't see that on my iPad. This one is. This one is. This one is not because it's got a sign, because sine of x is not a polynomial. So this one is not. This one is. This one is not. And this one is. Yes, 5 is a polynomial. It's just a polynomial of degree 0. So it would be considered a rational expression. A polynomial is an expression that has variables and numbers. Variables to varying degrees. Positive degrees, I guess I should say. And you can have a degree 0. So that's why 5 counts as a polynomial. Okay? So, simplifying rational expressions is very much like reducing fractions. All fractions that are common, all fractions that are common of the numerator. Oh, what did she type? All fractions that are common of the numerator and the denominator are eliminated or canceled, right? So in the first one, I've got 2 8s that are gone, right? We just simplify the fractions. You guys know how to simplify fractions. So on the bottom question here, which is correct and why? So 2 plus 3 divided by 2 equals 3, or 2 times 3 divided by 2 equals 3. So which one is correct and why? Write it on your paper. Or on your notes at home. Sorry that I don't have it, unless you printed it off. And you guys at home can type in your answers in the chat box, if you would. I'd appreciate it. Thank you. Probably say in the numerator and the denominator. Now say y. Oh, nice, Hannah. Okay, I think everyone that's answered in the chat box has said this one. And I would say my reason is because that one includes factors, and the first one is addition. So addition, you can't cancel out factors. You can only cancel out factors and not anything with addition. Addition doesn't have factors, okay? So we're all dealing with factors. So speaking of factors, we're going to be factoring today, and we're just going to do a just real quick review of factoring. So if we're only factoring out, the first thing we can factor as the greatest common factor, that's a factor that's in all three terms, such as 24x squared plus 16x has an 8x in both terms. Sorry, you guys here. So I can factor out an 8x, and it leaves me with 3x plus 2. So if I look at the first example or first problem to factor out, what goes into all three terms, I think that would be a 2x squared. So if I take 2x, I'm trying to find out what goes into all three terms. So my number is 8, 4, and 10. So what goes into 8, 4, and 10 is 2, right? And then what goes into x to the fourth, x to the third, and x squared is x squared. That's the biggest number that'll go into all three of them. So it has to go into all three terms. Does that make sense? Mm-hmm. Okay, so if I factor 2x squared out of 8x to the fourth, I should get 4x squared. And then I should get negative 2x and plus 5. And that's all that it factors. It doesn't factor. Okay, so I'd like you to go ahead and do A and B, please. Okay, so if on A, I'm going to factor out a 3x, and I get left with x to the fifth minus 3x minus 1. And then on B, I'm going to factor out x cubed and y. So I would get left with y plus 3x plus 5x squared y squared. Nice. Nice job, you guys. Questions? You guys okay in here? Pretty easy so far? Awesome. Good. Okay. So the next time factoring we're going to go over is factoring quadratics when a equals 1, right? So we're going to make it a little easier at first. So the way I kind of think about it, right, I need two numbers that multiply to be negative 15 and add to be 2. So that should be 5 and negative 3. So it should factor to x plus 5 and x minus 3. Done. Right? You guys remember how to do that? Anybody not remember how to do that? Same thing on the second one. Two numbers that multiply to be 24 and add to be negative 10. 6 and 4. Yeah, negative 6 and negative 4. So x minus 6 and x minus 4, done. Okay. So go ahead and do, okay, so really quick, right? So A should be x minus 9 times x plus 1. Sorry, I was just reading some answers in the chat box here. B should be x minus 3 squared. C should be, this one, I need two numbers that multiply to be -9 and add to be 0. So that's -3 and +3. So this one should be x minus 3 and x plus 3. And then the last one should be x plus 10 squared. Okay? Okay, awesome. All right, so that's the easy factoring, right? Now we're going to go to a little bit harder factoring when a is not equal to 1. So what do we do? Yeah, when a is bigger than 1, right? It's a little harder. A couple different ways you can do it. I usually use the little box method. Some people don't like it. You can do guess and check, whichever way you want to do it. But, right, so I think I've showed this to you guys before. Morgan. So 3x squared goes in here, -8 goes here. Then I need two numbers that are going to still add to be 2. It still has to add to be my middle number, but it's going to multiply to be 3 times -8. 3 times -24. So I'm pretty sure that would be 6 and -4. So 6x and -4x. And then I'm just going to factor my box. And then whatever I factor out, right? It's a multiplication table. So whatever I factor out is going to be my answer. So what comes out of 3x squared and 6x would be 3x. And -4x and -8, -4. And 3x squared and -4x should be 2x. No, it should not be 2x. What the heck? Oh no, it should be 1x. Wow, it should just be x. Should just be x. Okay, and this should be 2. And then you can just check to make sure that all the whatever's equal inside the box is right and it's correct. So this means it factors to 3x minus 4 times x plus 2. Done. Questions? I'm going to do it again. Okay. And then again, so I need something that, let's see, 5x squared goes here, -6 goes here. So I need two numbers that still add to be 10. And this time it's going to multiply to be -30. So, ooh. Multiply to be -30 and add to be 10. 10 and 3 don't work. 15 and 2 don't work. I don't think this one works. Huh? Needs to multiply to be -30 and add to be 10.
There's nothing else that goes into 30?
5 and 6. But one of them would have to be negative. Because this is a -30, right? That means one of the numbers has to be negative. So 10 and 3 doesn't work because that means it would be 7, add to be 7. 15 and 2 don't work because that means it would add to be 13. Okay, Miss Martinova, good job. I don't think this one works.
You know a cheat sheet?
No. No, we don't do cheat sheets for each other. Jeez, that would make too much sense. Because we barely have enough time to get notes done for each other.
So you just make these without an answer in mind?
Yeah, mostly. So, but that's okay. You need to know that sometimes they don't factor, right? So this one just doesn't factor. So does not factor. Right? Is it okay that it doesn't factor? Yeah, it's okay that it doesn't factor. There are some things that don't factor. So this one just doesn't factor because there's nothing that multiplies to be that. So if we go to the next page, we're going to do some more. Do you want me to do one more with the box?
Yes.
Okay. You guys are like, yeah, please do. Okay. So maybe I'll do one with the box. Okay, here we go. So let's do B, because look, there's no terms in here. Let's do this one. Why not? Right. Boy, this is going to be fun. Okay. So I have 25x squared and negative 81. So now I need two numbers that are going to, I don't have a middle term, so that means that it has to add to be 0 and multiply to be 81 times 25. 2025.
Just divide.
I thought it had to add up to 81 or negative 81.
Nope, not if there's, if it does if A is 1, but A is not 1 this time. Does that make sense?
Yeah.
A is not 1 this time. So I need two numbers that multiply to be 20, 25.
You know what they are?
No, that's why that's why I have my calculator.
You just check, like, how
Just do square root.
Yeah, I have to open Desmos. For some reason, my phone won't turn to the side. Square root 20, 25. 45. Pretty sure it's 45 and it has to be the same number. We already know because it has to be 0, right? So it has to be the same number.
Well, wouldn't that add up to, oh, it's negative.
It's 45 and negative 45.
Well,
Sorry, it should be negative. Sorry, Owen. So 45x and negative 45x. So now if I factor, this should be 5x minus 9 and 5x plus 9. Yeah, 5x plus 9. So this factors to 5x minus 9 times 5x plus 9. Done. Beautiful. Okay, you've got 3 to do. I'll make it, oh, you guys can see it on the screen. Sorry. And I don't know why. There we go, stop. And I probably should start recording. Sorry. So that's 10x and 2x. And if I factor, I can factor 2x out of here and a 1 out of there, and a 2x out of here and a 5 out of here. And then the nice thing is you can always double check, right? I know that what's inside my box is going to add up to be this because I made it that way, right? I made it that way. So this is a multiplication table. You can multiply it back out to make sure I'm going to get this. I can multiply it back out to make sure that these terms are right, especially when it comes to signs. Sometimes you have to double check your signs, but just make sure that your signs are right. And then it's 2x plus 1 times 2x plus 5. And that's it. And we already did that one. So we're going to do this one. So I've got 6x squared minus 12. So I need, it's going to add to be 1 and multiply to be negative 72, which is 9 and negative 8. 9x, negative 8x. So 3x, negative 4, 2x, and 3. Yeah, that should be it. So 2x plus 3 times 3x minus 4, done. And then the last one is 7x minus 4 times 7x plus 4. Questions? Not too bad? Everyone okay? Okay, now we're going to throw everything together and cancel. Okay, so this is, now we're going to get to rational, where we're really in rational expressions. Okay, so I get this really nice, beautiful rational expression, right? And how I do it, what we're going to do literally from now on for like the next 3 or 4 days is factor. We're factoring and canceling. Okay? So I'm going to factor whatever I can. So out of the top, I can take a 2 out of the top, and I get left with x plus 3. And in the bottom, let's see, it factors to 3 and 2, I believe, plus 3 minus 2, right? And then the x plus 3 is on the top and the bottom. That makes a 1. So that means my answer is 2 over x minus 2. And that's my answer. That is it simplified. That's what?
That's gonna get hard,
Why?
because it's just this stuff, but longer.
Yes, it is. Wait till we start multiplying and dividing. By the way, we do multiplying and dividing first in rational functions, and then we do adding and subtracting, because adding and subtracting is harder. Think about adding and subtracting fractions with like denominators and unlike denominators. And now we have variables in there. You can do it. I know you can. Okay, so we're going to factor again. This time I'm going to factor both the top and the bottom because they're both trinomials. So I think this one's going to be 4 and 3 this time with a negative 4 and a positive 3. And then multiply to be 15 is 3 and 5. Add to be 8, so they're both positive. X plus 3 and x plus 3 make a 1. So what I'm left with is x minus 4 divided by x plus 5. And that's it. Nice. Okay? Any questions? Okay. And then, great. For the next one, for number 3, let's see, I think I can simplify the top and the bottom first by factoring a 3 out, and I get x squared minus 2x minus 3. And then I can factor a 2 out, so I'm going to get x squared minus, not 2, I think that would be minus 3, minus 3x minus 4. And now I can factor my trinomial that's inside the parenthesis. So I'm going to get 3 times, let's see, that would be x minus 3 and x plus 1. And 2 is going to be x minus 4 and x plus 1. So those go away. And I get left with 3 times x minus 3 all over 2 times x minus 4. And basically you leave them factored out. So I would leave my answer this way. In factored position. Factored position. Factored form. Okay, any questions so far? Don't look at me that way. It's okay. It'll be fine. Okay, let's do, oh, there's only 3 more on this page. Okay, go. So I'm going to go ahead and do these 3 problems. So if you're already ahead, great. So this is going to be factor a 3 out, and I get 2x minus 1. And then on the bottom, I didn't use the box because I know the factors of 2 are just 2 and 1, and the factors of 1 are just 1 and 1. So, I mean, there wasn't a lot of choices there. And I figured since I'm probably going to cancel something out, it's going to be 2x minus 1 and then plus 1. And then I just multiplied it out in my head and it was right. And so these cancel out, and I get 3 over x plus 1. So I just kind of did that in my head, right? Sometimes you can make jumps like that when you're doing this, when you're factoring. So it kind of makes it a little nicer. So 3 times x squared minus 16 all over 6 times x squared minus x minus 20. And then I've got 3 times x plus 4 times x minus 4 all over 6 times x plus, oh, no, not plus 5. Oh, I'll do it this way. Plus 4 times x minus 5. I can write it either way, right? So, and then 3 goes into 6 2 times. So I should get x minus 4 over 2 times x minus 5. Okay, talk to me. What?
Oh, you can, okay. I didn't factor out the 3 on the top.
Oh, yeah, you need to factor out the 3 on the top. Okay. And then for C, let's see, x minus 3 and x plus 2 all over x plus 2 times x minus 2. And the x plus 2's go away. So I get left with x minus 3 divided by x minus 2. Okay, beautiful. And then, okay, there's 6 more problems, I think. And then 1 more question to answer. Well, 2 more questions to answer, but we're doing great. We are actually doing great. Everybody here seems to be almost ready, so I'm going to go ahead and start this. So D factors to x plus 3 times x plus 5 all over x plus 3 times x plus 6. And those go away. So I get left with x plus 5 over x plus 6. And then E is x plus 3 times x plus 4 divided by x plus 2. Oh, should probably be a plus sign in there. X plus 2 times x plus 3. Cross out. So I get x plus 4 divided by x plus 2. And then I'm going to factor 2 out of the top. And I get left with x squared minus 4 over x squared minus 4x plus 4. And then if I factor again, I get 2 times x minus 2 times x plus 2 all over x minus 2 times x minus 2. Those go away, and I get 2 times x plus 2 all over x minus 2. G is x plus 4 all over x plus 4 times x plus 2. Those go away, and I get left with 1 all over x plus 2. And then H, I'm going to factor a 4 out, and I get x squared minus 1. And I'm going to factor a 2 out, and I get x squared plus 2x minus 3. So 4 times x minus 1, x plus 1, all over 2 times, x minus 1 times x plus 3. So those go away, and this becomes a 2. So I get 2 times x plus 1 divided by x plus 3. And then the last one, so fun. I made a little box, right? I just did it really quick and sketched it out. And I did 4x squared and 9. And then what multiplies to be 12, adds to be 12, multiplies to be 36 is 6 and 6. So 6x and 6x. So it was 2x and 3 and 2x and 3. So the top factored to 2x plus 3 times 2x plus 3. So the bottom, I didn't do a box. I just said, oh, well, 2x squared factors to 2x and x, and 3 factors to 3 and 1. And so those go away. So I get left with 2x plus 3 divided by x plus 1. Done. Questions? Lucy's still writing. Not too bad, right? It's okay, Lucy. There's other people still writing too. So on the ones you missed, I hope you understand what happened and what went wrong and everything. So there's one more question below. I'll slide back up in a minute so you guys can look at these again. But there's one more question that says, if you were given the expression x over x squared minus 1, would it be acceptable to reduce it like this? X over x squared minus 1 equals 1 over x minus 1. Explain.
It's a tough one.
No.
Why?
Because the x up top is not multiplying by anything.
Okay.
If it was x times x up top, then you could take out all the x's.
I could? So what have we been doing the whole time? What before we start canceling anything out, what do we do?
Factor.
Factor. So does anything in this equation factor?
Yes, the bottom, right?
The bottom factors. What does it factor to?
I have to do it box.
It's x plus 1 times x minus 1.
Okay, great. So the bottom factors to, so if I was just to look at this, right? X over x squared minus 1. The bottom factors to x minus 1 times x plus 1. Is there any ones I can make in there? Where it's the same on the top and the same on the bottom?
And you, wait, say that again?
Is there any ones I can make? That's what when I cancel, that's what I'm doing, right? It's the same thing on top and the same thing on bottom. That makes a 1.
No.
Really? Yeah, there's none in here. Good. Yeah. So can I do, so does it work with what they did? They said they made a 1. Is there a 1 in this equation? There's not.
I was right.
Oh,
Yeah.
It was close.
Yeah. So,
Saying since x is just x to the 1,
yeah.
and when you divide it, subtracting, so it would just be x minus 1 would be the answer, right?
No, this would be my answer. It's already simplified. There's no simplifying it.
But when you...
So look at it this way. What if I said that x equals 3? Okay, I just pulled that out. I just came up with it, right? So if this is true, then this should equal this. It doesn't matter. When I put x in for 3, they should equal each other, right? Okay, so let's do it. Let's put in x for 3 for both of them. So if I put it on the first one, it should be 3 over 3 squared minus 1 equals 1 over 3 minus 1. Is that equal to each other?
Yeah, I wasn't taking the 1 into account.
Yeah.
If it was x over x squared, it would just, the answer would be x, right?
1 over x.
Yeah.
You're saying if it was x over x squared,
Yeah.
then it would be 1 over x.
Okay, so why is it different here?
Because this is not x squared, this is x squared minus 1.
Oh, okay.
Are you okay with that? There's something done to that x squared, something extra done that's not multiplying.
Yeah.
Okay. So yeah. So I always think it's easier if I say, well, what if x equals 3, and then plug it into both of them and see if they're equal. If they're not equal, there's no way that it works. Does that make sense? Yeah.
Yeah.
Okay, and then there's one more question there isn't a question for you guys. Oh, no, it's not on this one. It's on the next one. So it's on the next lesson. Okay, so that's it. So you're going to